Welcome, I'm Mrs. C, and this is Math Defined. Today we're using algebra tiles to solve algebraic equations. Let's get into it. Equations are like puzzles. We have to figure out what number x is so that when we add 1 to it, we get 3. Let's break it down step by step using algebra tiles. The green tile will represent the variable x, and the yellow tile will represent the plus 1. So now we have x plus 1. Next we need an equal sign and 3 more yellow tiles. Combining these 3 tiles gives us positive 3. The algebra tiles give us a different way to visualize the equation x plus 1 equals 3. Now let's use them to find the value of x. We want to get x by itself on one side of the equation so that we can find out exactly what x equals. Right now, there's an extra yellow tile, or plus 1, with it. So we need to remove the one yellow tile, which will leave just the x on the left side of the equation. But to keep things equal and balanced, we must do the same thing on the right side. We'll remove one tile, leaving 2 left on the right side of the equation. So using just the algebra tiles, we see that x equals 2. Now let's solve this equation again without using the tiles. We still need to get x all by itself on the left side. And just like before, there is a plus 1 with the x. How do we get rid of the plus 1? We remove it by doing the opposite operation. So we will subtract 1. And to keep the equation balanced, we will subtract 1 from the other side as well. On the left side, the 1's cancel each other out, leaving just the x. And on the right, 3 minus 1 is 2. So x is equal to 2. But it's always a good idea to check your answer. We do this by replacing or substituting the variable x with its solution. So the x is replaced with a 2, and we bring down the rest of the equation. 2 plus 1 is 3, so both sides of this equation are balanced. Let's model the equation p minus 5 equals negative 2 using the algebra tiles. The variable p is represented by this green tile, and this time we have 5 being subtracted from the variable p. So we will need to use 5 red tiles to represent the minus 5 or negative 5 in the equation, giving us p minus 5. Then we'll use 2 red tiles to represent the negative 2, resulting in the equation p minus 5 equals negative 2. Now let's use the tiles to find the value or the solution for the variable p. Just like before, we need to get the variable all by itself on the left side of the equation. But right now we have 5 negative or red tiles with it because 5 is being subtracted from the variable p. So the only way to undo this subtraction is to do the opposite and add 5 yellow or positive tiles. And to keep the equation balanced, we need to add 5 yellow tiles on the right side as well. Now going back to the left side of the equation, we see 5 red tiles paired with 5 yellow tiles. When we added the 5 yellow tiles, we in essence created 5 zero pairs, because combining a negative tile or a negative 1 with a yellow tile or a positive 1 equals 0, effectively canceling them out, leaving just the variable p. And on the right side of the equation, we can cancel out these 2 zero pairs, leaving positive 3 on the right side. So the solution for p is p equals positive 3. Now let's find the solution again using the traditional method. We know that we need to get the variable p all by itself on the left side of the equation. Since the 5 is being subtracted, we need to perform the opposite operation and add 5 to both sides of the equation. The 5's on the left will cancel each other out, leaving the variable p. And on the right side, we have negative 2 plus 5, which is positive 3. So again, we see that the solution is p equals positive 3. Now let's check our solution. Since p is equal to 3, we will substitute it in place of the variable to get the equation 3 minus 5 equals negative 2. Remember, in order to subtract, we need to add the opposite. So positive 3 plus negative 5 is negative 2, and the equation is balanced. To model the equation y plus 4 equals -7, we'll need to use both positive and negative tiles. We'll start on the left with the green tile for the variable y, and then add 4 yellow or 4 positive tiles, giving us y plus 4. Now to represent the right side of the equation, we'll add 7 red or negative tiles, giving us -7. Now we're ready to solve. In order to isolate the variable y on the left side of the equation, we will need to add 4 negative or red tiles. And to keep the equation balanced, we will do the same on the right side. Looking at the left side, we see 4 zero pairs that cancel out, leaving the variable y. And on the right side, we don't see any zero pairs. Instead, we see 11 negative or red tiles. So the solution for y is y equals -11. Now let's solve it using the traditional method. In order to isolate the variable y on the left side, we need to subtract 4 from both sides of the equation. The 4's on the left side cancel out, leaving just the variable y, and on the right side, combining -7 and -4 gives us -11. So the solution for y in this equation is y equals -11. We'll check our answer next just to make sure we were correct in our math calculations. We'll substitute the solution for y, -11, into the equation -11 plus 4 equals -7. Then adding positive 4 to -11 results in -7, and our equation is balanced. Thanks for watching, and I hope all these examples helped you out. And until next time, keep math awesome.